Hey folks, and welcome back to the Material Editor Devlog. In this fourth video, we will finally start developing our first proper material. And this material will be used in the Project Slide game project, but it will also be used as a test bed for the code generation that we will get to later on. As always, if you haven't seen the previous three parts, be sure to check those out first so that you know what we're talking about here. So in the previous video I mentioned that most of the core node editor functionality was done, and basically that meant that you could use this editor here to create node graphs by dragging nodes onto the view. You were able to adjust their properties, connect pins together. All of this base functionality was already working last time, but having a generic node editor doesn't mean that you can actually create materials with it. You have to essentially take that generic node editor and turn it into a dedicated material or shader editor. And so what I've been doing since the last video is essentially take the editor that I have and make it more shader aware in many different ways. And we'll take a look at a few. So first of all, let's create a new material and let's set the vertex format to only be position. It notifies us that it doesn't support default shader passes. That's just because we don't have default shaders for shadows and ambient occlusion using this position only vertex format, but that's fine. So if we create a new material, it gives us a vertex and a pixel shader pass, and you can add more if you want to use geometry or tessellation or whatever. So I've added some new nodes since last time, and I think we will actually concentrate on the vertex shader and the pixel shader stages for this video series. I have a few materials that use tessellation as well as geometry shaders, but they tend to be kind of rare, so I want to make sure that the classical combo of a vertex shader and a pixel shader work well before diving into those. So both of these stages have received input and output nodes. So if we drag an input node here, and we can drag an output node here, you can see that these have these icons, and now this is so small now because it only has the position that you can't really see it. But you now have dedicated input and output nodes for each shader stage, and essentially you want to have exactly one output node per stage, because the data needs to go somewhere. And you can have an input node as well. You most likely always will, but that's not necessarily a requirement. You can procedurally generate all the data for the stage if you want to. But in a typical stage, you will have an input and an output, and then you will have something in between, and that is essentially up to the material. Well, as you can see here on the vertex input node, it only has a position currently, and as you might have guessed, it is because we have only the position set. So if you add the position color, it actually switches to the pixel shader stage by default. But now you can see that it actually gained a color pin here. So that's one new thing. I have these dynamic node types that sort of react to other things in the editor, and they know a little more about the context in which they live. There are also some other new dynamic pins, such as not actually the color, but the vector node, which you can use to produce anything from a one-dimensional to a four-dimensional vector. So if you make a vec2, for example, it only displays the x and y, and now we have the C pin, etc. And you can either just fill in those values right here, or you can connect it to a pin. So you can do like a vector that is X and Z are set to constants, but then receive the Y from somewhere else. And all of this is sort of things that we've covered before. But the dynamic nature of this is something that's new, and it can be surprisingly complex. For example, now what happens with this connection here, if we turn this into a 1D, well, it needs to disconnect it because the pin went away, etc., etc. So all these are seemingly simple things, but very important to make an easy to use shader editor. I've also just polished the UI a little bit. For example, here you might see that these now have distinct colors, and you can see that the vertex stage is now identified by this orange here. The pixel shader stage, on the other hand, has these blue nodes, and this is just to sort of start to build some kind of like easy to read visual identity, so that when you see something with like a blue input node, you should pretty quickly see that, oh, it is actually a pixel shader that we're talking about. And yeah, now we can see the input and the output icons a little better. These are probably not final, but just something to make it even more clear that, okay, this is an input node and this is an output node. And obviously in something like a pixel shader, if you did this, if you had two output nodes like this and you connected them together, this would not be valid as a pixel shader. So when we get to the code generation starting in the next video, this is a case that we'll want to actually handle, and just let the user know that, oh, you can't have two pixel shader outputs. And indeed, you can't have a vertex shader output here like this, because we're now in the pixel shader stage. So all of this is just to make the editor a bit more aware of what a pixel or what a shader is, and bring it from being just a generic node editor into a shader editor. Another thing that I did was essentially hook the material editor into the game engine's resource system. So you have all kinds of tools belonging to the engine. So we have a curve editor here. This is something that I based on the XNA curve editor. So you can add points like this, and you can generate a curve, and you save the curve as whatever you want. It saves it out as an XML file. And when you load it back in, essentially everything it needs to know is in that curve file. It gets the points out of there, and it can work on the data using just the information that's in the curve file. And that's fine. However, for certain tools, it's not necessarily enough to know only what is in the actual document file that you are working with, in this case a material file. Sometimes you need to know sort of what is the game project that this material is going to be used in. For example, when we start generating the code, it will most likely want to pull some shared editor code from some kind of shared library location, and so on. And one good example of a case where it's good to know the game project that you're in is in the new texture resource node. So this is a node where you load a texture, and you can show a preview of it like this. And when you click this button, it actually allows you to browse everything that is in the current game object. So I was thinking one of the early materials that we could try making with this new editor would be the wheel material. So we can just type wheel here, and we get, oh, okay, we have three diffuse textures for wheels, and you can immediately see this preview here of the UV atlas. And of course, this is not something that you could really do if the only information that the editor knew about the material was in the material file, because obviously we don't have a list like this in the material file itself. So this is something that I've spent a few days on now, hooking this into the system so that the editor knows the game project that it's going to be used in. And we can actually see, you might have seen, this is now the startup window. You might have seen when I started the editor in previous videos. This is now the editor startup window. They look the same because it's essentially copy pasted. And I have this project file here which sets some information about which game executable to run, where the work folder root is, and this is the information that is now used by the material editor. So over here, if the material editor would want to show some kind of 3D preview for the material, it could run this game and use it as the renderer for it. That is, for example, how the editor renders the scene. And that's also how here we have another one. There's the asset browser. As you can see, it also used as the same project. We're working on slide, and when we open it up, if we click here, oh, I don't have the asset server running. It just notifies me. So let's make that happen. And since the asset browser application knows what game project we're working on and where the game exe is, it can render a preview here. And this is something that we could do if we wanted. We could integrate the 3D preview as a view in the material editor later on, using just the information that we now have hooked into the material editor. But let's if I can type correctly, let's look at the wheel material. So I think what we'll want to actually produce in this video series using the new material editor is this. So this is the wheel for essentially for this car, which you can currently see here without the wheels. So this is the so-called Lancer, the small nimble attack vehicle, or scout vehicle, if you will. So there is this object called car2 detached wheel. This is an object that sort of is spawned if the car loses one of its wheels. But yeah, it uses the same material as the actual wheels that are rendered when the car has them attached. And you can see here that it uses objects, vehicles, car2 wheel textured .bin material. So if we take this wheel textured and just look for it here, we can see, okay, we have three of them. So car2 is this car that we're interested in, and we can open this up. And as we've talked previously, currently our material system uses just JSON files to set up the information. So this is the stuff that we'll want to actually put in node material form, so to speak. So we have a few passes. You have an opaque pass. It uses a shader program like this, and we'll actually want to look at this the source for this shader program to figure out some of the layout for the material. It has a pipeline state, but it's set to empty, to an empty object, which means that it just uses the default one, so we don't have to tweak and fiddle around with the pipeline state settings, or we shouldn't have if I have the same settings in the editor as I do in the old system. And then we have some uniforms. So we have a material constant buffer. We should actually be able to generate the new shader code without any kind of constant buffer. We should just actually be able to hard code these values in. So we have 3 colors. We have a specular power. We have essentially just a boolean receive shadows value, and then we have two padding values here that I can also get rid of. Or actually I can't get rid of them, but I can automatically add them. I can have the code generation pad them. Or in this case, since we should be able to hard code everything, I won't actually need them. And then we have a diffuse texture, which is wheel diffuse. So this is the object that we already looked at in the texture node in the editor. And then we have a sampler, which is just set to linear wrap. And we briefly mentioned the default passes already. We have the object casting shadows, so it uses the shadow map default material, and also for the 2 different kinds of AO that's supported, which is SSAO and HBAO. Actually it's HBAO plus, but the pass is called HBAO depth. So this should give us a pretty good idea of what we have to actually put into the node graph to make this work. But let's have a look at this mesh diffuse shader next. So we can also find it here if we go to the asset browser and we search for mesh diffuse. And this is now the way that the old style material shaders are built. Typically you have an HLSL file which contains the actual source, and then you have a bunch of basis shader files that are essentially like the entry point to the shader compiler. And these basis shader files they point to this and typically define different defines so that this produces like a slightly different variant. And that is something that we can also just automate in the future. We can generate different permutations of the shader, and it will all just be handled behind the scenes for us without us having to do anything. So that's very nice. So let's open this up, and we can see what we have. So there are a few includes and some of those if-defs that I mentioned. So some of these some of these guys, like mesh diffuse painted, for example, probably defines this object painting, and the one that uses the distance dissolve defines this, and that in turn turns on different things here in the actual shader itself. So then we have these 3 resources that we already saw in the basis material. We have the constant buffer, we have the texture, and we have the sampler. So that should be easy to map to a node graph. And then we actually have just an include for a standard mesh vertex shader. So I'm not going to go super deep into how shaders work and what you can do with them, but if we open the containing folder here, and we can go to HLSL include and standard mesh vertex shader. So this defines, first of all, a vertex in struct. So this needs to match the vertex format that we set in the material. So in other words, we can generate this struct also from whatever we have in the material. And then we have a vertex out, which we probably also can generate. But here we have a bunch of if-defs again, because it needs to support all kinds of different configurations. And then we have a basic vertex shader called VS. Actually, let me just make this a little larger so that everyone can see. And this is essentially your standard vertex shader for simply transforming the points of the mesh into the correct space and forwarding everything to the pixel shader. So typical things that you might want to do in a vertex shader are like animations or scalings or something like that. If you just want the mesh to appear exactly how it looks when exported from your 3D modeling software, then you will want something like this. You can do all kinds of fancy things, but most of the actual like surface look calculations are typically done in the pixel shader. So the vertex shader is supposed to be easy to just make like a pass-through one, so that you can then do your fancy lighting and whatnot in the pixel shader. So we'll want to have a way to essentially just transform all the points and vectors into the correct space and forward them to the pixel shader. And that will be essentially the same as just including like a standard mesh vertex shader like this. So then if we go back to the mesh diffuse, so the actual shader file, we had the include here, and next we have the pixel shader. And again, this has a bunch of if-defs here. So if we have painting enabled, you can just paint on objects directly in the editor. We need to actually apply the paint object. If you dissolve the object by distance, then you actually call clip here, calculating the actual dissolve for the pixel that you're processing, etc., etc. And then there is essentially the standard, if you will, scene lighting functionality, which is all of this. So you give it a bunch of lighting parameters and you get a lit color out. And after that you can apply global illumination. The GI system is pretty bare bones still, or it's essentially work in progress. It kind of works, but it needs a lot of work, so I typically don't have it turned on at the moment. But it's here still, it can be used. And then finally we apply the fog. And this is also something that we most likely will want to make it really easy to just get this included in our shader, because it's something that is very common to have. And then of course if you want to change it, you should be able to do that by modifying the node graph. And yeah, then it returns a pixel data struct which contains like the color and the bloom color and whatnot, so that it can calculate the bloom if the color is very bright and so on. So this is what we'll want to actually put into the node graph, and this seems like quite a lot of code, and it is, but the node graph should be, at least in the beginning, it should be simple enough that we actually bundle a bunch of, like, for example, this code here, we can bundle under one node, at least in the beginning. And then when we have that working, we can add, we can split it up into smaller nodes so that we can more easily modify the behavior. But it should be really easy to just get this included, because this is, like I said, it's common stuff. Okay, so let's get started on this, and I will actually just open up the material editor and we can get going. So we can hide those and open it up. So if we look at this still, and we need to go back to the vehicle blueprint. So it was this one. So if this is the material that we'll want to make, and it currently lives in objects with vehicles, car2, wheel textured, then we'll probably want to create the node material in the same place, same folder. And you can see all of these paths are actually relative paths. Same thing here if we create a new texture resource node, for example. It just says fallback diffuse texture. If you go here and it says basis textures fallback diffuse texture, and that's because these are not actually file paths. They are derived from file paths, but they're not file paths that you can just copy paste into Windows Explorer and it will find the file for you. The resource paths, and this is a resource path by the way, the resource paths are derived from the actual file that this texture is generated from. So if we have this, for example, fallback diffuse texture, we can search for it here. There's a PNG called fallback diffuse texture, and we can find it in the Explorer like this. But when this gets converted into a format that can be read by the game, it can be accessed by the game using this path over here. And so that's why this is not absolute, because obviously when you ship your game, this file will not be in the same position and same folder as on my work machine. And indeed, in the shipped game, the texture will most likely be loaded from a pack file, like a compressed archive anyway. And the same thing goes for these. So these are all resource paths rather than actual file paths. So you have a mesh and you have a material. So if we go to Objects, Vehicles, Car 2, we can create our new material there. So let's create a new material. Press No. We'll want the same vertex format, because if we compare the format of the standard mesh vertex shader that we looked at, you can see that the vertex in actually matches this. This is the standard one. So position, tangent, binormal, normal, text chord, and position, tangent, binormal, normal, text chord. So this is the correct one for us. And as for the main render pass, well, this uses the opaque one. So the main render pass is opaque, and as we already mentioned, it does use the default shaders for the passes that support those. So these are all fine. Oh, wow. Yeah, that's a bug. Okay, there's something there in the dialogue that I need to actually fix. So making these videos is a great way to actually find bugs, as we've previously seen in the videos. But yes, I'll fix that later. So let's immediately go ahead and save this in the correct folder. So here we have the work folder root, and it was Objects, Vehicles, Car 2, and in here, and we can save it as wheel. And you can see the whole path here, wheel.basis node material. And that way it will be placed in the same folder as this wheel texture. I think it's called wheel textured just because I had another non-textured test material or something when I was making this, so we don't need the textured postfix there. Okay, so we have the pixel and the vertex stages, and that's correct. Let's start with the vertex shader, because it's gonna be super easy. As I said, we have the input node and we have the output node, and we need to put something in between, and I have prepared a node for that. So local to world, let's see what we have here. So the vertex input gives us these, and these are all the components that are in the mesh data. So we can simply hook these up to the local to world node like this. Very uninteresting, and we can align them like this nicely. And this output node expects them in world positions, so it is gonna be almost just a straight pass through. We don't have a color, so we just leave that unconnected, and we hook up these. And you can see that we can support multiple UV coordinate channels if we want to. This input doesn't actually give us that, but if we were to select like one of these two, or one of these two, or one of these two, we would actually have more UVs here in the input, so we could connect those as well. But for now, we'll just connect UV0 to output UV0. Yes, and that's it essentially. That's our vertex shader. It looks quite kind of simple, and of course the tricky part will be actually generating the code for this. So we're not out of the woods yet, but we're getting there. And now for the more interesting part, which is the pixel shader, and tends to be the more interesting part in most materials. But again, let's start with the input and the output, because we know we'll want these two. And the output for the material, which is essentially here the input node for the input pin for the output node, is a color. And you can compare that to this here, where we have this lit color, which is a float 4. So that's a four-dimensional vector, RGBA, and we pass it into calculate pixel data here. So you can think of this pixel shader output as this calculate pixel data, and we give it a color. So it is this color right here. And as for the pixel shader input, we can just temporarily, this is not gonna actually work, but we can temporarily just drag a vertex shader output here, and you can see that currently these actually match completely. Well, let's put them like in the other way. So you can think of the vertex data entering this vertex shader output node here, and then being magically given to this guy on the pixel shader's side, and then you can sample the data from here. And my idea for how to actually do this is that the actual struct that we'll get generated for this shader, so essentially this guy here, the vertex out pin, which in the old system is here with all of these if-defs. The layout of this vertex struct out will depend on which of these output pins here you have connected. So, you know, currently we have, for example, UV0, so this one, but we don't have these two. So if you don't connect UV1 or UV2, it can just simply leave out those members of the struct. So that is how I imagine the data flowing from one stage to the next. Okay, so I also prepared, like I said, we want to make it easy to get the standard stuff going. So I made this scene lighting node here, and this gives us like most of the complexity from the pixel shader immediately. It essentially wraps everything which is in here. It just does it in a slightly more optimal way. But for example, here you have the apply fog to pixel, and this function actually needs to check like a global value which is set in a constant buffer, which is not really ideal for shader code. Well, here we'll have the fog toggle here as a checkbox. We can just simply toggle it here, and that will give us the opportunity to generate different code based on whether it's on or not. And receive shadows is another toggle here. Well, it's actually input here into the lighting parameters. So you have kind of the same thing. You have position, you have normal, and you can see those two being given there. Then you have some like global. You can see these global, this like small g, and then something. These typically come from a constant buffer somewhere. So the camera position and camera forward direction. These two will indeed come from like a shared constant buffer, and the scene lighting will just be smart enough to figure those out on its own, because the scene constant buffer will always be there when rendering a material. Then you have specular power, which is a float. Well, it's given here. So this can be just input here directly, or you can give it through a pin if you want to calculate it like on the fly somehow. And then you have these ambient color, diffuse color, specular color, and also the diffuse texture. So it's these four. Some of you might ask, like, okay, what do we have? Why do we have diffuse color and diffuse texture color? And well, that is currently how the basis lighting model works. Essentially, you typically give it just a diffuse texture, and then you modulate it using this diffuse color if you want to, or this can just be pure white, and you can use the diffuse color right away. It perhaps is worth mentioning that the basis engine doesn't use any kind of PBR system or anything like that. It's very much like a traditional old school renderer in that way. Anyway, this gives us an out, and this is from the color. You can see that this is a vector. Like, these are all vectors that have these like turquoise pins. This is a float, so it has an orange pin, and so that's the sort of the end of the pixel shader done right there. But now we need to set up all of this other stuff. So let's start with position. Well, we already have the position here in the correct form, so we can just plug it into the position, and the normal we can plug into the normal like this. And this scene lighting doesn't use, actually it uses normal here, yeah. So if we had a normal map, we could use oh, actually I misconnected that. It's supposed to be from normal to normal. Yeah, we don't have color currently, so we leave that unconnected. But if we were using a normal map, we would use the tangent and binormal here to actually calculate a normal vector for us together with the normal, and then plug that into the normal rather than just plug sort of passing it through. But this is a very simple material, so we don't use any kind of normal maps on the wheels currently. And then we have UV0. Okay, so this is what we should use to actually sample the texture. So let's add a sample texture node here, and we can plug that into the UV, and then we can plug the output into diffuse texture color like this. And the filtering to use, I think, was probably linear wrap, right? And we can check that out in the material as well. Yes, linear wrap is the sampler that we'll want to use. And as for the texture, let's drag one in. Oh, not a sample texture, but a texture resource like this. We can align these perhaps a little nicer, so, and then connect that, and then we need to set the actual texture to use. So that's wheel diffuse, and that's car2 wheel diffuse. So now that we put this here, we get a few of them. We have car2 and we have car3. Well, it's car2, and now we can see that yeah, this looks correct. So that is the one that we'll want, and we can leave that open or we can close it. Doesn't matter. So then we have these colors left. So we have 3 colors, and we can add 3 color nodes. So I showed you previously we have like a new vector node that allows you to produce a vector anywhere from 1 dimensions to 4 dimensions. And as with most shader systems, like colors are also vectors. So this is just another way to actually produce a vector using a color vector node. You could just as easily do it with this if you wanted to like punch in the numbers there. So we'll want 3 color vectors. like this, and we'll hook them into the correct pins. So this is diffuse. Let's have a look at the diffuse value in the old material. And diffuse is this one, and it's just white. It's pure white. So we can just put in here like F, 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 F. And that's white. And the next one is the ambient, and that's D8, D8, D8. And so let's copy that in. You can see like a slightly, it reacts to diffuse light a bit more than it does to ambient light, like this. And then we have the specular, and I think the specular is very low. Yeah, it's 191919 or 191919 in hexadecimal. Yeah, and if you just looked at this very quickly and you were like, I want the ambient light to be a little less bright or something like that, it might be a little tricky to go like, which one is like, okay, yeah, that's the ambient color. But I added a system where you can actually just add a comment above the nodes for cases like this. So we can write ambient, and it appears right above the node, which can be kind of handy. So we can add notes to these guys here, like this. So when you get back to this material after like a month, you can very quickly see that, oh, okay, those are the three colors. And maybe we can make this a little more compact, something like this, and bring this in. Maybe move everything a bit closer to the. You can see the slightly thicker origin lines here, and this is where the editor currently, when you load it up, it will sort of move to that position like this. So we can just move these things a bit closer to them. There we go. So that is our pixel shader done for now. And this should now map or match the old material pretty closely, and that is of course assuming that I create nodes like this, or rather I have nodes like this actually generate the code in a way that matches the current material. But that's the plan, and you don't really have much choice over how to actually light the object with a node like this, because it's sort of like the standard or the average way to do it. And I do realize that it's not going to be enough for the game to only use lighting nodes like this. You'll want to actually be able to open this up and compose it out of nodes rather than just use a simple node like this. But I think we need to start somewhere, and I think this is a pretty good way to get going, because this way I can fairly quickly convert current old style materials to use the new node system and just get the same result back as I did previously, which is a good place to be in the beginning. Right. I think this pretty much does it for this video. In the next video we will start to actually look at generating the code for this material and perhaps even seeing it in the game, but I think that might be a couple of videos away still. I should perhaps add that as I am recording this, it has been more or less exactly 2 weeks since I started the project, and my goal was to have like a very simple version of this running in the game in 2 weeks. So essentially having this material that we just created running in the game in 2 weeks. And it seems like I won't be able to get that done. But that doesn't matter all that much. I have done other things besides this editor this week as well, and I think things are going pretty well, so I'm going to continue doing these videos so that we actually get this material in the game, and I can actually say that, okay, was this worth the time investment or not? Well, I think I can already say that it pretty much was, because this opens up so many new things and opportunities for optimization and easier workflow that I previously had, that I'm pretty certain it will be a good investment of my time. But yes, just as a sort of situation update on the schedule side, no, we didn't actually make it in 2 weeks, but also no, it doesn't really matter. So with that out of the way, I think I'm gonna end here and get cracking on the code generation. And please leave a like if you enjoy this kind of stuff. Ask in the comments if you have any questions or comments or observations, and I will see you in the next part. Bye.